Alright, team. Let's reel it in. Today, we're diving deep into the currents of opportunity costs. Specifically a model that's as crucial to our kelp cake business as strong fins are to a long swim, the Newsboy model. Now, picture this, it's sunrise, and the tide is perfect for our kelp cake sales. We've got eager merfolk and sea creatures lining up, ready for a delicious breakfast. But here's the Kraken-sized question, how many kelp cakes do we bake? Too few, and we lose sales, a tragedy. Too many, and we're left with soggy, unsold cakes, a waste of precious ingredients and resources. That, my friends, is where the Newsboy model comes in. It's not just for land dwellers selling newspapers, you know. It's about balancing supply and demand in the face of uncertainty. Think of it like this, demand, how many kelp cakes will our customers want? We can look at past sales, tide patterns, and even the mood of the local dolphin pod, they love kelp cakes. But, it's never an exact science. Supply, how many kelp cakes are we going to bake? This depends on our ingredients, our baker's speed, and our oven capacity. The sweet spot, the Newsboy model helps us find that sweet spot where we maximize our profits. Cost of understocking, imagine we bake too few cakes. We lose out on potential sales. Each customer who swims away disappointed is a lost opportunity. This is called the lost sales cost. Cost of overstocking, now, imagine we bake too many. We're left with soggy, unsold cakes. We've wasted our precious ingredients and our baker's time. This is called the salvage cost, or the cost of unsold inventory. In our case, it is the cost of feeding the leftovers to the sea urchins. Calculating the right amount, the Newsboy model uses probability and statistics to calculate the optimal number of kelp cakes to bake, balancing these two costs. Let's list out the variables. We'll use W for the wholesale cost, the per unit cost it takes to produce the kelp cakes. I'll sell them for the per unit retail price P. The salvage value is the per unit amount we make back when feed the leftover stock to the sea urchins, S. Finally, for the demand distribution, we'll let f of x denote the cumulative distribution function of demand. That is, f of x is the probability that the demand will be less than or equal to x. Don't clam up at seeing the formulas. It's all about finding the critical ratio. We consider the selling price, the cost of making each cake, and the cost of unsold cakes. It helps us determine the probability of selling a certain number of cakes. Now let's associate values. Let's say we make the kelp cakes at a wholesale cost of $1, so W equals $1. We'll sell them for $2.25, so the retail price P equals $2.25. We can get the salvage value S equals 45 cents for the remaining cakes. To solve this, we need a ratio that balances the cost of being understocked, a lost sale worth P minus W, and the total cost of being either overstocked or understocked. We have a critical fractal of P minus W over W, which is $2.25 minus $1 over $2.25. This equals about 0.56. For demand, let's look at a normal distribution. This is often referred to as a bell curve, because it looks like a bell when drawn out. We'll use a normal distribution with a mean U of 50, which represents the expected demand forecast, and a standard deviation sigma of 30, which is the error between actual sales and the forecast. For each kelp cake we don't sell, it will cost us $1 minus 45 cents, or 55 cents. We can call this the overage cost. If the demand exceeded our inventory, we would say that we had an underage cost, which would be the price we could have sold each kelp cake for, $2.25, minus the wholesale cost $1, or $1.25. The critical ratio is the underage cost divided by the sum of the overage cost and underage cost. In this case, the denominator is 55 cents plus $1.25, which is $1.80. The numerator is the underage cost $1.25. So the critical ratio is $1.25 divided by $1.80, which equates to about 0.69. Where the lines tied together is where the critical ratio equals the probability in the normal demand curve. The f of x is 0.05016, so multiplying that by the standard deviation sigma equals 30, we get about 1.5, so we should make 50 plus 1.5, and you'll want to round up to produce more, so we'll make 52. We can use this model for our special occasion kelp cakes, like the Coral Celebration Cake or the Triton's Treat. We can apply it to our daily sales at different locations, the bustling Reef Market, the Quiet Cove, or the School of Seahorse Children. We can use it to determine how many limited time only cakes we should make. Now, let's surface what questions you have. Remember, understanding the Newsboy model is key to minimizing the costs of lost sales while also minimizing the overage costs. This will keep our profits financially buoyant. Now, who wants a kelp cake?